High-performance airports, achieving net zero energy through an energy management control system, a collaboration between San Francisco International Airport and HNTB. We are Joshua Heath and Raniel Camacho from SFO, and Jennie Santoro and Ken Poon from HNTB. One of the largest and most widespread challenges of the airline industry is energy. Airports are typically campus environments with terminals, hangars, and offices spread out over a large area. A lot of power, water, and gas is needed to keep airport operations running and passengers comfortable and safe. When you combine all of the support needed to run an airport with a 24/7 operation, this creates an enormous strain on the energy grid. For example, SFO uses approximately 446 gigawatt hours of energy annually. This includes electricity and gas, which is typical for U.S. airports of this size. This amount of energy is equivalent to powering 66,000 California homes annually. In addition to infrastructure constraints and 24/7 operation, airports also have very specific energy challenges. These include 400 Hz power to keep planes powered when grounded, which is one of the largest power consumers in the entire airport, and preconditioned air to provide fresh, cool air to the planes. Not helping the energy challenge are the many standalone systems, including mechanical HVAC controls, electrical power, tenant metering and billing, and flight tracking. This is all a direct result of low-bid public projects over time. At SFO, each terminal operates in its own bubble. This is an issue because the energy resources are shared and affect each other. This is typical at many airports today. Oftentimes, the airport energy management systems are disjointed. It's a mix of different systems that don't talk to each other and can't pivot in turn based on the real-time energy demands. What happens is that energy bills end up skyrocketing and sustainability goals fall short. At SFO, our EMCS is comprised of multiple proprietary systems that need their own server and computer just to operate and track energy. Newer systems like Terminal 2 and parts of Terminal 3 have electronic direct digital controls with sophisticated sequencing and programming, which is good. While older systems like Terminal 1 are controlled with pneumatics that are outdated and failing. They have rudimentary programming logic, and they have the inability to communicate with others. In short, the SFO EMCS is in the dark. We don't have real-time data and can't see what's going on between different areas and other systems. Consolidating the energy systems together is a challenge in itself. Each system often runs in its own silo, walled off from each other and not sharing information. Additionally, there are multiple quote-unquote central databases with conflicting information, making it difficult to establish a true energy baseline. This all leads to an environment where an airport operates inefficiently. Ideally, airports should not have these barriers between systems. Eliminating the silos of segmented data and consolidating all system data into a single cloud or locally hosted data source. After all the energy information is centralized and data is shared freely, we can analyze in real time exactly how healthy an airport is running. After analyzing data, we can make more informed decisions on which recommendations, ideas, and projects will reduce the greatest amount of energy. Then we can implement those ideas into our operation and track progress. This is an iterative process called continuous commissioning. This continually tracks and reduces our energy use until airports get to a level where net zero energy becomes achievable. This is a process all airports can use to reduce our reliance on the grid. This continual process of tracking and measuring data, communicating with other energy systems, analyzing that performance, recommending energy efficiency measures and projects, implementing those recommendations, and starting the process over and over again is called an Energy Management Control System, or EMCS. An EMCS process tree or architecture would look like this. All airport systems feed into the airport network, including natural gas, HVAC, water, electrical power, and lighting control. The airport network allows for unrestricted data flow throughout all systems, serving as the superhighway where the most accurate data travels. Certain systems, like HVAC and lighting control, not only provide data out, but can also be controlled through the airport network. From the airport network, the EMCS receives data that impacts operations. The EMCS can also send control commands back to systems to operate more efficiently based on the real-time demands. From the EMCS, data is sent to the IT central server, or in SFO's case, ITT data storage, where real-time data can be streamlined and historical data can be stored. The real-time and historical data is then sent to data analytics programs to find inefficiencies and make recommendations to fix those issues. The data analytics can be done as an in-house or on-premise application internally at the airport, or sent to a hosted or cloud-based analytics provider. An additional benefit of the central ITT data storage is that it provides a single source of truth and a secure location where data can be sent outside of the secure IT network. In an ideal EMCS architecture where continuous improvements are made, a feedback loop is involved. After data is analyzed, it is sent to engineering and/or architecture to analyze performance and make recommendations. These would either be engineered solutions or changes in architectural designs for retrofits or new construction projects. Then, operations, policy changes, or construction projects will be done to implement the recommendations into the airport and eventually into the EMCS. After implementation, the process starts again and again. What makes this so special is that there is no formal, repeatable process for energy reduction, especially in airports which have very unique energy challenges. The EMCS fills that gap, so airports can follow a process to continually track and reduce their energy. An EMCS reduces risk by identifying gaps in the operations, so airports can address weaknesses and leverage strengths. Plus, we can save a ton of operating dollars and implement only the highest value designs for future projects and expansions. This integrated approach is the next level in operating a high-performance airport. This integrated approach is already being used at SFO. The IT team has taken flight arrival data and shared it with taxis, Uber, and Lyft drivers so they know when passengers arrive and which boarding area to wait in. Previously, taxis would wait at a random boarding area and lose out on business if the demand was in another location. With this information, they can be more strategic. So as passengers get off the plane, the taxis will get notified and immediately move to that location. And as passengers walk through the terminals and get their luggage at baggage claim, they will have a car waiting for them so they can easily get on their way. We take this to another level when we add an EMCS, and we really see an operational and energy reduction impact. So as passengers get off the plane, again, the taxis would get pinged and head to the baggage claim area. In addition, the HVAC system will also command to turn on at the arrival gate, so the space is cooled based on real-time demand and ramped down when not occupied to save energy. The movable walkways can be controlled to slow down when not in use, and ramp up as passengers arrive and get closer to the walkways. This saves energy since the walkways are not running 24/7 at full speed. And lighting can be optimized as well. As passengers move from one location to the next, lights will turn on fully to help guide passengers to their right baggage carousel. Then, when areas aren't in use, lights can reduce to every other fixture to save further energy. And again, when passengers are ready to go, their ride is waiting to pick them up and get them on their way. So this brings us back to the question, how does the EMCS provide value towards energy reduction and eventually net zero energy? By leveraging an EMCS, we can reduce operational costs. An EMCS also brings down energy reduction to promote sustainability goals. And an EMCS enhances the traveler experience by now having the ability to adapt to the passenger. To implement the EMCS solution, we start at the smallest level. Simply put, the EMCS is a tool comprised of hardware, software, and data analytics to control how our building performs so we can manage, track, and optimize our energy use in each space. If we go from the smallest level, which is spaces, and move up to the terminal level, the EMCS implementation plan is a phased approach. That process at SFO looks like this. Phase 1 will be at Terminal 3 Boarding Area E. This is one of SFO's most modern boarding areas, with a lot of infrastructure already in place. Although there are minimal hardware upgrades, we'll still need to do many integrations and system adjustments. This will be a proof of concept, where we can try new strategies and troubleshoot issues until all systems perform optimally. Then we can take those lessons and best practices and implement them in the next phase. We continue this process as we go around the terminal campus, learning and troubleshooting and getting more efficient each new time. The EMCS implementation process applies not only to retrofits, but full new construction of terminals, as in the case of Terminal 1. Standards and requirements can be given to new construction projects for full integration into the established EMCS. This process can be fully vetted, then duplicated at other airports. Finally, at the highest level, the EMCS approach can be implemented throughout the industry. The EMCS works for airports large and small, and different climates, whether hot, cold, humid, or dry. Ultimately, the EMCS can help reduce airports' dependency on energy, reduce costs, and lead the way for climate change. Thank you.